Hey everybody, this is lesson 2.5, linear inequalities in two variables. These problems can be found on pages 124 through 127 in your Algebra 2 textbook. So let's get started. The objectives for today, you're going to be able to graph linear inequalities on the coordinate plane and solve problems using linear inequalities. All right, so I'm going to just give you a little bit of basic information to get us started. And so let's talk about a linear inequality. You've been working with linear equations, but now we're going to be doing linear inequalities. So instead of having an equal sign, we're going to be using the greater than or less than inequality symbols. All right, so the first thing I want to tell you about is the boundary line. So what is a boundary line? It's the line that divides the coordinate plane into two regions. So let's do an example of that. So let's take this line right here, which is y equals 2x minus 4. And you may recognize that that line is in the y equals mx plus b, which is our slope-intercept form. M is the slope and B is our y-intercept. So let's go ahead and plot this. Here's our -4, which would be our y-intercept. So let's go ahead and count down 1, 2, 3, 4 on our graph. And there is our first point. And then our 2 is our slope. And remember, slope is rise over run. And our 2 is just 2, but we know that that's an understood 1 there. So we're going to rise 2, run 1. So let's go ahead and rise 2, run 1, rise 2, run 1, rise 2, run 1. All right, so now we have some points, and I'm going to just go ahead and try and get all those in there. Okay, so there is our line. It's not a very straight line, but it's pretty good. All right, so you can see that this line divided the coordinate plane into two regions. All right, it has this upper part region and a lower region. Okay, so when we're dealing with inequalities, we're going to be saying that either all of the upper region, this whole region right here, is true, and this region in this case would be y is greater than 2x minus 4, or the other region is going to be lower than, all right, and so this region in this particular case is going to be y is less than 2x minus 4. So we're going to be working on that in a little while. Now this boundary line is pretty important the way it looks also. Just like when we do a graph, when we just graphed in the one-dimensional here, and we have like say y is greater than 5. All right, so what we would do is circle our 5 and draw our arrow that y is anything greater than. But notice we circled it because 5 is not included. All right, but if y is greater than or equal to 5, then we color this in, shade this in, and then that tells us that 5 is included. Well, our boundary line is going to be in the same kind of way. If the line itself is included, if it's actually equal, so if we use the greater than or equal to sign, we're going to have a solid straight line the way it is right now, even though it's a little crooked. But if it's not, if it doesn't include, if it's just greater than or less than, then we're going to actually use a dashed line. So this would be a dashed line instead of a solid line. So those are the two things I want to cover with you before we go further. So let's do a couple of problems using that information now. All right, so here's our first problem. It says graph the linear inequalities. And so we see again our problem is written in mx plus b form. All right, but this time y is less than mx plus b. So we can go ahead and using the same thing that we did before, remember our b is our y-intercept. So our y-intercept in this problem is going to be 1. So let's just go up 1 on our y-intercept. And then here, our m, which is our slope, is 1/2. And remember, That's 1/2, and that is the rise over the run. So we're going to rise 1, run 2. Rise 1, run 2. Rise 1, run 2. All right, so first thing we want to do is draw our boundary line. And notice there's no equal sign on here, so we're going to do a dashed line. I'm going to go ahead and put a few more points in here. There we go. So I'm going to do a dashed line through my points. All right, now there's my boundary line. Now, this is saying that we want y to be less than. So most likely it's going to be in the lower quadrant part of this coordinate plane. So let's just check a point just to make sure. Let's check this 0, 0, our origin. So what we're going to do is we're going to replace x and y with 0, 0. And I'm thinking that's going to make it true because it seems like y is less than would be down here. Sometimes it's not, but we want to always check a point to make sure. So let's go ahead. Our original problem was y is less than 1/2 x plus 1. So let's fill in our 0, 0 here. 0 is less than 1/2 times 0 plus 1. So 0 is less than, that's 0, 1. And 0 is less than 1. That is true. So we know that this bottom section is going to be shaded. So any number that you choose in here will be true. We'll make this equation true. Actually, this inequality true. So let's just check and see that anything up here in one of these higher ones would make it false. So let's choose an easy number. Let's try over 2 up 4. Let's just try this point. So this one shouldn't be true. We think that that's going to be false. 2, 4. So let's put it in here. Our original equation, or inequality, sorry. So 4 is less than 1/2 times 2 plus 1. All right, so our 2's cross out, so we have 4 is less than 1 plus 1 is 2. And that is not true, and that's why we haven't shaded anything up in our upper region of our coordinate plane. All right, let's try another one. Let's look at this one. This one says y is greater than or equal to 2. So no matter what x is, y is always going to be 2. So let's just find where y is 2. Here's where y is 2 right here. No matter what x is, y is going to always be 2. And notice that we have a greater than or equal to sign, so our line is going to be solid. So here's our solid boundary line. And you can go ahead and put your arrows on the end. And now our problem says that y is greater than 2. So any of the y's greater than 2 are going to make this true. If y is 3, that's bigger than 2. If y is 4, that's bigger than 2. So any of the y's up there are going to make this inequality true. If we choose a y that's less than 2, then it's not going to be true. Say 0 is not greater than 2, so that's why it's not shaded in this section of our coordinate plane. All right, why don't you try 2 on your own real quick, turn the video on pause, and then come back when you're ready. Okay, welcome back. So let's look at this this problem. It says graph the inequality. So we look at our first equation and we can see that it's written in the y equals mx plus b form, except instead of the equal we have the greater than or equal to sign. And remember, our b is our y-intercept. So our y-intercept is going to be -2. So let's go to -2 and plot that one. And it says that our m, which is our slope, is 3. And that's an understood 3 over 1. And remember, slope is rise over run. So we're going to rise 3, run 1. Rise 3, run 1. Rise 3, run 1. Okay. And I'm going to actually go down 3, but also left, so that makes it. Okay, now this says that we have greater than or equal, so our boundary line is going to be a solid line. So I'm going to try really hard to get a solid line. There we go, to go through there. All right, so here's my boundary line. Now it says y is greater than, so my instinct is to tell me that all this y side is going to be greater than, but I need to check a point to make sure. All right, so I'm going to try the origin again because that's really easy one. So in place of my y, I'm going to have 0 greater than or equal to 3 times 0 minus 2. So 0 is greater than or equal to, that makes 0, minus 2 is 2. So indeed, 0 is greater than negative 2. So our instinct that told us that y would be on this side greater is correct. So we're just going to go ahead and shade that whole side in. That means anything on this side of the coordinate plane is going to make that equation true. So you could pick any point over here, and that's going to make our inequality true. All right, but let's just check to make sure that we did it right. So let's choose another point on the side that it should be false. So let's choose this point, over 2, down 2. So that point is 2 comma negative 2. So let's rewrite our equation one more time. 3x minus 2, and fill in our x and y. So our y is negative 2 greater than or equal to 3 times 2 minus 2. 3 times 2 is 6, so negative 2 is greater than or equal to 6 minus 2, which is 4. So negative 2 is not greater than or equal to 4. So all of the numbers on this side of our boundary line are going to be false, and that's why we haven't shaded it in. All right, so the next one says y is less than negative 3. Well, that's telling us that all points of y are going to be negative 3. So let's go to negative 3. 1, 2, 3. Here's negative 3. All the y's, no matter what our x is going to be negative 3. So that's actually a horizontal line. Our boundary line is a horizontal line, and it says y is less than negative 3. So all the y's that are less than negative 3 gets shaded in, so everything below is going to be true. Negative 4, negative 5, all of those are less than negative 3. If I choose something up in the higher range up here, then I have got an inequality that is not true. So let's say 1. 1 is not less than negative 3, and that's why none of this is shaded in. All right, let's move on. The next type of problem that we're going to do is example 2 on page 125. It's graphing linear inequalities using intercepts. And I really love these problems here, so I'm just going to draw a little heart in here because I love these problems. Don't you? All right. Well, let's keep on moving on. So the problem says to graph 2x plus 3y is greater than or equal to 6. And this time, they've given us a new way to use, we're going to use our intercepts. So we're not going to write it into y equals mx plus b anymore. This time we're going to use the intercepts. So the first one says the y-intercept. So let's find our y-intercept. And remember, the question we ask is what is y when x is 0? Because our intercepts are going to be when we have 0 comma something, and when we have something, comma, 0. These will be our two intercepts. So this is x, y, and this is x, y. Okay, so what is y when x is 0? So let's fill that out. 2 times 0 plus 3y is greater than or equal to 6. So that's just 0. So 3y is greater than or equal to 6. Divide both sides by 3. So y is greater than or equal to 2. So let's go ahead and put our 2 in here and plot that point 0 comma 2 over 0 up 2. So there's our y-intercept. All right. And now we have to do our x-intercept. So to find the x-intercept, we say, what is x? We're looking at this problem now. When y is 0. See, here's our y equals 0. So let's fill in our problem again. What is x? So we're going to say 2x plus 3 times 0, when y is 0, is greater than or equal to 6. So 2x greater than or equal to 6. Divide both sides by 2 because we want our x by itself. So x is greater than or equal to 3. So our x-intercept is going to be 3. So let's go ahead and mark that down. 3, 0. And there it is. All right. So now we have 2 points. So the next thing we want to do is notice what our inequality says. And our inequality says that it's greater than or equal. So that means this is going to be a solid line. So our boundary line is going to be a solid line. So I'm going to do my best to get a solid line. See if I can do that. There we go. So it's a solid line. So there's my boundary line. So now we need to choose a point. Now it says greater than, so I'm assuming that it's going to be up in this higher part, but we need to find a point and choose and see, just verify that that's true. So let's choose an easy point. Let's choose 2, 2. All right, so we're going to use 2, 2 as our checking point here. Our original equation said 2 times, we'll go ahead and say 2, plus 3 times 2 is greater than or equal to 6. So 2 times 2 is 4, 3 times 2 is 6, 4 plus 6 is 10, greater than or equal to 6. And that is true. So we know that everything in this part of our coordinate plane is going to be a true for that inequality. So we can put any number in and that will be true. Let's just check one more time to make sure that we did. Now we see that we didn't shade 0, 0. So we are expecting these, all these numbers, these points to be false for our inequality. So let's just put it in here. I'm going to write it over here. 2 times 0 plus 3 times 0 is greater than or equal to 6. So 0 plus 0, 0 is greater than or equal to 6, and that is false. So you can see that all the points on this bottom part of our inequality in our graph is not true. So none of that's shaded in. All right, so go ahead and try one on your own. Turn your video on pause. When you're finished, come back and we'll do the answer. Okay, so let's give it a try. Again, we want to graph this by using the intercepts. All right, so in the question we ask when we're finding our y-intercept is what is y when x is 0? So that means we have a 0 comma something. All right, so let's see what is y when x is 0. So 3 times 0 plus a negative 4y is greater than 12. All right, so we actually have 0 plus a negative 4y is greater than 12. Now I'm going to have to divide by a negative 4 on both sides. And it doesn't really matter right now, but we'll make a note of it in just a minute. We have to change our sign when we divide by a negative 4. So we're going to have y, change our sign, negative 3. So we're going to just go ahead and put our negative 3 right there so we have our first intercept. 0 over 0 down 3 for our y-intercept. All right, let's figure out our x-intercept. Remember, what is x when y is 0? So we're going to say 3x minus 4 times 0 is greater than 12. So 3x is greater than 12. So divide both sides by 3 to get our x on its own. X is greater than 4. So in this place, we're going to say x is 4, y is 0. So there is our x-intercept. So we're going to go over 4, up 0, 1, 2, 3, 4, up 0. Okay, let's check our graph. It says just greater than. It's not equal to. So our line is not going to be solid. It's just going to be a dashed line. All right, so there's our dashed line. And now we've got to figure out what point. Now this is a clue over here when we had to change our sign that just shading up above might not be correct. So let's check and see. Let's pick a point and see if 0, 0 is true. All right, so let's put 0, 0 back into our equation. This is 0, 0, and see if it's true. So 3 times 0 minus 4 times 0 is greater than 12. So 0 minus 0 is greater than 12. That is not true. So we're not going to be shading this upper area. All right, so let's try another one. And let's try a point down here. Let's try over 1, 2, 3, down 3. So let's try 3, 3. Okay, 0.33. And we hope this one's going to be true. So 3 times 3 minus 4 times 3 is greater than 12. So 9 minus 12. Oh dear. What did I do wrong? Oh, that was 3, negative 3. Sorry. Over 3, down 3. So our y over here, let's get that in right. Negative 9 plus a negative 12. That's still not bigger. Let's see here. I know I have our point right. What am I doing wrong? 3, negative 3. Oh, all right. I'm so sorry. Let's get these points in. You probably already saw what the mistake was. Let's see here. Let's erase all this. Okay. So the point that we're checking is 3, negative 3. So 3, negative 3. There you go. Now the x is 3 times 3 minus 4 times a negative 3. All right, and so that's plus the opposite. That's got to be greater than 12. So this is 9. Negative 4 times a negative 3 is actually a positive 12. So 9 plus 12 is 21, and that is indeed greater than 12. So we can shade this bottom area. Sorry guys, I get confused sometimes with my negative if I'm not being really, really careful. And so you guys probably are having the same problem sometimes when you deal with negative numbers, so we just have to learn to be really, really pay close attention to details. All right, let's move on. Okay, we're going to do a problem-solving application, so let's read it together. A local theater charges $7.50 for adult tickets and $5 for discount tickets. The theater needs to make at least $240 and so to cover the rent of the building. How many of each type of ticket must be sold to make a profit? If 20 discount tickets are sold, how many adult tickets must be sold? So we actually have two things that we're going to have to solve for. How many types of each ticket must be sold to make a profit? And if 20 discount tickets are sold, how many adult tickets must be sold? So you have two things that we're going to have to solve. Now, this type of problem, you can see, you could have many different combinations to get there, and that's why making a graph is going to be so helpful to see what our actual numbers need to be. So let's turn the page here and look at some things. So let's first look at some important information. The theater sells tickets $7.50 for adults and $5 discount, and the theater needs to make at least $240. So let's set up an equation to see if we can figure that out. All right, so let's say our adult prices are going to be the, let's make our adult prices be the X's. Okay, let's make these be the adult prices, and let's let the Y be our discount prices. So this is going to be our discount. All right, so our adult prices are $7.50, $7.50. And we're going to multiply that by the number of adult tickets that are sold. So we're going to call that our X because we put that on our X side. All right, now we're going to also sell some discount tickets, and our discount price is $5, and we're going to sell some of those, so we're going to multiply that by our Y because we set that as our Y. And when it says is at least That means it has to be greater than or equal to 240. All right, so now we've already, believe it or not, set up an equation to solve and figure out what numbers need to be sold. So let's look at what our equation is. 750x plus $5 y has to be greater than or equal to 240. Now, instead of doing our y equals mx plus b, which is actually a lot of work, we can solve this by just finding the intercepts. So remember, to find the intercepts, the y-intercept, that means we're going to have 0, comma something. So it means when x is 0, what is y? So 750 times 0 plus $5 times y is going to be greater than or equal to 240. So that's $5 greater than or equal to 240. So let's divide $5 by both sides. And when we do that, we get y equals 48. All right, so our y is 48. Let's just put these as 10, 20, 30, 40, 50. So we're going to put our point here, y equals 48. All right, and let's find our x-axis, our x-intercept. So to find the x-intercept, we say what is x when y is 0? So that's going to be our point. So let's fill out our price again. We're going to say 750x plus $5. Our y is going to be 0. Sorry. And that has got to be greater than or equal to 240. So we have 750x is greater than or less than 240. Divide both sides by 750. And that gives us x has to be greater than or equal to 32 when you put that in your calculator. So let's go ahead and plot this 10, 20, 30, 40, 50, 60, 70. Let's do that. All right. And so x is going to be 32, so let's just put that about right here. So now we have both of our intercepts. So now it says greater than or equal to. So we can go ahead and make a solid boundary line. There we go. Here's our solid boundary line. And so we need to know, and logic tells us that anything down here is going to be less than, we're not going to make our full $240. And anything up on this side is going to get us more profit. So let's just check a point to make sure. Let's check over 3, up 3. Let's check this point. So let me get my calculator out real quick. Sorry. Okay. Yeah. Okay. Here's the calculator. So 750 times 3 plus $5 times 3. Oh, that's 30. 30. Oh, yeah, don't forget that. Greater than or equal to 40. All right, so 750 times 30 is $225 they would make. And if they sold $35 tickets, we would have $150. And 225 plus 150 is 375, and indeed that is 240. All right, so we have one more thing. So we know that any amount of tickets that we sell up here is going to give us a profit, make it more than 250. Okay, so let's just do one more thing because our question had one more part to it. The question said, let's see, okay, what would be the profit if the adults, okay, it says, number 2, what is the number of adult tickets that must be sold to make at least 240 if 20 discount tickets are sold. So let's just look right here and see. Here's 20, and it matches up with our 20 here. Now, I wasn't really careful with my drawing, so we're going to assume it's going to be somewhere probably between 20 and 30. So it says that if at least, it says, let's see, if 20 discount tickets are sold, how many adult tickets need to be sold? So we can use our equation. And I'm going to erase some of this so we can see our equation better. Whoops. Let's see. Okay, let's answer this question. So if 20 discount tickets, so that's going to be our y. So 750x plus $5 times 20 tickets, it's got to be greater than 240. So now we can easily solve that. We can see that, let's see, 5 times 20 is $100. So 750x plus 100 has to be greater than or equal to 240. So let's subtract 100 from both sides. So that's going to be 140 greater than or equal to 750x. And so when we divide both sides by 750, we have 140 divided by 750. It would be approximately 18.6. So we would actually need to sell 19 of the adult tickets if we sold 20 discount tickets. And that's pretty close to what we thought it would be, somewhere around the 20. So that's good. All right. Try one on your own. Put the video on pause and give it a try. Okay, so here we have a cafe gives away prizes. A large prize costs the cafe $125, and a small prize costs the cafe $40. All right, so the cafe will not spend more than $1,500. How many of each prize can be awarded? How many small prizes can be awarded if 4 large prizes are given away? So let's call our small prizes X, and let's make our large prizes Y. So this is going to be our large prizes, and we'll fill in our numbers in just a minute here. Okay, so let's see. We're going to sell small prizes. This is a large price costs the cafe $125 and a small costs $40. So let's say 40 times the small, which are our X's, plus 125 times our large, which we're going to make be our Y. And that has to be less than, we're not going to spend any more than 1,500. All right, so there's your equation. And we can draw our boundary line now by using our intercepts. So when x is 0, that would be 0, what would y be? 125y less than or equal to 1,500. Divide both sides by 125. Both sides by 125. Put that in your calculator real fast. 500 divided by 125 is 12. So y is going to be 12. All right, and so let's just do 2, 4, 6, 8, 10, 12. So here's our y-intercept. And so now let's find our x-intercept. So what is x going to be? 40x plus, when y is 0, it's going to be less than or equal to 1,500. Divide both sides by 40 to get our x by itself. So we have 1,500 divided by 40 equals 37.5. So that's going to basically be 38. Okay, so let's just use tens on here. 10, 20, 30, 40, 50. Okay, and this is approximately 38, so that would be right here. Now it says it's greater than or equal to, I'm sorry, less than or equal to, but it's got the equal, so it's going to be a solid line. So let's see if I can get a solid line in here. There we go. There's our boundary line. So the question is, we want to spend less than, so that's going to be in this column over here. So let's just choose something equal. Let's choose an easy one. Let's say when x is 10, y is 2. So when x is 10, 40 times 10, and y will be 2, so plus 125 times 2. And we want that to be less than or equal to $1,500 because we don't want to spend more than that. So we know that 40 times 10 is 400 plus 125 times 2 is 250. It's got to be less than or equal to 1,500. And 400 plus 250 is 650, and that is certainly less than 1,500. So we would actually shade this area. Now there's one more part to our question. It says how many small prizes can be awarded if 4 large prizes are given away. So let's rewrite our equation using 4. Let's see, I'm going to erase all this for a minute. Okay, so here's our equation again. We have 4 large prizes, so we want to know how many small. So 40x plus 5 times 4 to be less than 1,500. All right, so 125 times 4 is equal to 500. Okay, so we have 40x plus 500 less than or equal to 1,500. So let's subtract 500 from both sides. That gives us 1,000. And so we have 40x has to be less than or equal to 1,000. So we're going to say 1,000 divided by 40 is 25. So 25 small can be awarded. And so we can just look up here and see if we give away 4 large ones, where does that cross? Right about here, which you can see is right at about 25. All right, just one more section. And don't you just love these problems? They are so much fun to do. I love doing them. It helps you use your brain more, and then that's really great. All right, I love these kind too. Don't you? Just love these problems. All right, well, let's just solve one more type of problem, then you'll be done. This kind is solving and graphing linear inequalities again. So what we're going to do here is, again, we'll just distribute this. This is just kind of a little bit more. So 2/3 times 2x is actually 4/3 x minus, and we distribute our 2 to both of those, 2/3 y has to be less than or just less than 2. So it says solve for y. So let's solve for y. So basically we're going to be getting it back into our slope-intercept form. So first of all, y is over here. We want y to be by itself, but we see that this 4/3 x is attached to the y with addition. So we want to undo that. And so we're going to subtract 4/3 from both sides. So there's our negative 4/3 x plus 2, and that has got to be less than 2/3 y. Okay, now our 2/3 y is, I'm going to get rid of that, is we still want our y to be by itself, so let's multiply by 3/2 and a negative 3/2 so that we can have y by itself. So if we multiply negative 3/2 on the left, we have to also multiply it by on the right. So I'm going to squeeze it in there. This marks out to be 1 y, but notice that I multiplied by a negative number, so I have to change my inequality sign. Okay, now I have to distribute this. I'm going to try and be really careful with my negatives here. Negative 3 times negative 4 is a positive 12, and 2 times 3 is 6. 12 over 6, so that's actually going to be 2. So let's just change our 12 over 6 is the same as 2x. And then we're going to distribute our negative 3 times 2 is negative 6 over 2, and that equals 3. So I'm going to go ahead and change that out again, and that's going to be a negative 3. So the answer on this one is going to be y is greater than 2x minus 3. And I didn't give us a graph on this, so I'm just going to sketch one out for us. Whoops. See if I can sketch one out for us. All right. And let's see. So y, okay, so our y-intercept is going to be negative 3. 1, 2, 3. We'll go ahead and plot that. And we're going to go up 1 over, up 2, rise 2, run 1. All right, let's get a couple of more on here. Rise 2, run 1, rise 2, run 1, rise 2, run 1. So here's our boundary line, and it's going to be dashed. It's not solid because it's not equal to. Okay, so here's our boundary line. And now we just need to pick a few points to make sure. So let's pick 0, 0 statement. So what we have is 2/3 times 2 times 0 minus 0, and we're going to find out if that is less than 2. So this whole thing is 0, so 2/3 times 0 is 0, and is 0 less than 2? It certainly is. So all of this section gets shaded in. And if you want, you can do it on your calculator too, but we're not going to do that right now because I can't get it on my computer very well. All right, one more for you to try on your own. All right, put your video on pause. When you're finished, come back. Okay, here we go, our last problem. Don't you just love doing these problems? I love these problems. I just love doing math. All right, here we go. So on your own. So first of all, we're going to solve for y. It says solve for y. So we're going to distribute our 2 times 3. So that's going to be 6y. That's plus a negative. So I'm going to be real careful with my negative numbers. 2 times negative 4 is plus a negative 8y. It's going to be greater than 24. All right, so solve for y. So first thing we're going to look for, we want y to be all by itself, but right now there's a 6x added to it. So to undo our adding, we subtract minus 6x from both sides. So that leaves us with negative 8y is greater than negative 6x plus 24. All right, now we still have this 8 multiplied to our y, so we need to undo that. So we're going to divide that by 8, and we're going to divide this by 8. So that, but this has to be a negative 8 and a negative 8. So that, what's that going to do to our inequality sign? It's going to change it. So it's going to be y is less than, and I'm going to go ahead and separate this into 2 separate pieces. Negative 6x over negative 8 plus 24 over negative 8. Okay, so now we can reduce this to a positive. 2 goes into that 3 times, 2 goes into 8 4 times, so it's a positive 3/4 x plus a negative 3. So y is going to be less than 3/4 x minus 3. Okay, so now we can plot that. This is in y equals mx plus b form. Here's our y-intercept, which is negative 3. So we're going to go down negative 3. And then our rise over run, we're going to rise 3, run 4. 1, 2, 3, 1, 2, 3, 4. And actually, that's all we need to do. And this is just a greater than sign. It's not equal to, so we're going to make this be dashes. Dashed line is our border line, is dashed. There we go. And now we have to choose a point. Now I'm guessing that it's going to, the greater side is going to be up here in this top section, but I don't know for sure. So let's choose a point to find out. So when we put, let's try 0, 0. So we're going to say 2 times 3 times 0 plus a negative 4 times 0 greater than 24. All right, so 3 times 0 plus 4 times 0, that's 0. 2 times 0 is 0. Is 0 greater than 24? No, it's not. So all of this top section up here is not included on our answer. So let's choose one down here, and I'm going to be real careful with my negatives this time. So this point is going to be over 1, 2, 3, down 3. So it's going to be x is 3, y is negative 3. So let's put this in here really carefully. 2 times 3 times our x, which is positive 3, plus a negative 4 times our y, which is negative 3. And we want that to be greater than 24. So 3 times 3 is 9. And negative 4 plus negative 3 is a positive 12. 9 plus 12 is 21. 21 times 2 is 42, and that is indeed larger than 24. So this section would need to be the one that is actually shaded in. So anything down below here is going to be true. Okay, so that is the end of our lesson today. I hope that you loved this lesson as much as I did. It was great fun. Shouldn't have been too tricky for you, but if it is, you can go back and read the problems again. And I will see you in class on Wednesday of this week. Okay, signing out. Have a great day. Hope you enjoy your lovely scene here.